Hello everyone, today we're back again on CodeForces. The Division 3 round starts. I'm not actually in competition, so for me it's not rated. But I will try to solve everything just for training purposes and as well for just for fun. Okay. So here we go. There are n nails driven in the wall. The ith nail driven is AI meters above the ground. One end of the BI meters long rope is tied to it. Okay, all nails hang at different heights, one above the other. One candy is tied to all ropes. One candy is tied. To take the candy, you need to lower it to the ground. You need to do that, or else can cut some ropes at one time. So, okay, so the ropes that are there is n the number of ropes. There's AI what meters it is above the ground, and then there's BI meters long rope. Okay, so is it guaranteed? It's guaranteed that it's not contradictory. So you need to cut all ropes that are above the. Oh no, actually this rope is more. So what is here? So so where is the candy? First we need to calculate where is the candy. So it's what you need to print, the minimum number of rows need to be cut. So where is the candy first? Where is the candy? The candy is the smallest from each rope. I will measure what is the smallest, or do I need to know where the candy is? Certainly the candy is not. Certainly the candy could be on the ground, right? Like this here, test. Certainly the candy could be on the ground, or certainly the candy could be lying somewhere, in which case you will cut all ropes which do not equal the count is simple. You will cut all ropes count is when A is where the nail is. A is bigger than B. So certainly that was kind of slow. Gets accepted. Let's go B. Oh, my camera just froze, so I'll switch down to. I could switch down to the integrated camera, just so we don't lose time. will switch to the song account. Just discard. Well, that's a bummer. Okay, I will fix this. Let's go solve this. Okay, it's fixed. I don't know what happened. Invented a tic-tac-toe for 3 players. It has classic rules. Game is won. Okay, so Earl wants to find the result of the game, either exactly one or end up in a draw. It's guaranteed that the. So do you just need to check which one? So you simply want to check first. You check. So I will repeat this 2 times. So I will repeat it for character. So character ch in either X or O. So I'll repeat this, and I say I will iterate through the rows, and win is going to be equal to if AFRJ is equal to character. If win, we're just going to print character, and we're going to end it here. So this is for iterating through the rows. Same thing if I iterate through the columns. And then there are 2 diagonals, so I will just say I'll iterate through the diagonal. This is the first diagonal, and then the second diagonal is n-1, so 2 minus this. This is the second diagonal, and then at the end is just draw. Oh, the plus can win as well. Okay, so the plus can win as well there. Well, no. Apparently I didn't read the game. The result of the completed, it has classic rules except for the 3rd player who plays with pluses. Each field contains either clause. The game is won when the player horizontal wants to find either exactly one of the 2 players ended in a draw. It is guaranteed. Either exactly one of the 2 players won or ended in a draw. It's guaranteed that multiple players cannot win at the same time. Yeah, of course, this is what am I doing here? This is like that. This is the one diagonal. This is the other diagonal, and this is the the normal diagram. Okay. CodeForces law. Rule of and another competition. This is just has registered for programming competition that will follow the rules of ICPC. The rules imply that for each solved problem, participant gets 1 point and also incurs a penalty equal to the number of minutes passed from the beginning. Yeah, in the final, the participants rank higher in case of ties. In total, n participants were registered for the competition. The rule of is a participant with index 1 is known that n problems will be proposed and the competition will last h minutes. Okay. A powerful artificial intelligence has predicted the values Tij, which represent the number of minutes it will take the ith of the jth problem. Yes, we'll become interested in what place he will take out of the competition. Okay. Okay, so we just need to kind of for each of these we will get the number of minutes penalty. So the other thing is, what is the Rudolph became interested in what place? So Tij problem, Rudolph's place in the final optimal if all participants solve problem in optimal order. But which one is Rudolph? Became interested. Rudolph is participant various one. So I'm just going to say this. There is n, there's h, or what is this? No. There's m, and there's the m, and then there's h. Sum is it will solve them. So first we need to solve them. And then the sum is to sort them, because we will solve the first the most number of minutes to take solve this, and then sum is equal to whatever sum we have here plus a of I, and then for this so for each participant we'll have this. So the I participant should have sum of this. Then we'll create return p of I, p of if p of a is equal to p of b, then return a small b, else, so here return p of a small p of b. Oh, and then if the sum goes above h, so goes above h, then we will break, and then we want to find which one. If p of I is equal to 0, cout I plus 1, return let me just print no, if order of I is equal to 0, then print I. Okay, so apparently always the first guy. So here in this yeah, but how many problems plus, so I need some problems here. So pi pair of first sort by problems. So sort by negation. So who has the most problems, then who has the least sum? So first he has 3 problems solved with 0, 3 problems solved with 0. So wait, that's not correct at all. How is AI 0? AJ, of course, here AJ. So first has 3 problems with 100. That's third place. Why second? In first example you get 2 points for and 15 minutes. Second player will solve only 1 problem. Well, yeah, first player will get 2 problems. Oh yeah, the first player will get 2 problems. Oh yeah, the sum of time. if time is this, and then time plus aj is bigger than age, then we break. The first has time of of course. Okay, so that makes sense. That's stupid. You run cancer, why? If they're equal, then A smaller than B. If not, this is smaller. So first problems, then the sum. More problems, and then the sum is this. Is essentially this. Right, but that doesn't change anything, right? Oh, it does change. Okay, so this actually does change. So what's wrong with my webcam? Gets accepted. Problem D. Rudolph and Christmas tree. Rudolph drew. I don't know what's wrong with the webcam. Drew Christmas tree and decided to print the picture. However, the ink runs out most inconvenient moment. And therefore, wants to calculate in advance how much ink he needs. The tree is a vertical trunk with identical triangle branches. Different heights. The thickness of the trunk is negligible. Each branch is an isosceles triangle with base D and height H. Calculate the total area. But here it's like. I see. So I will look like I will do some, because of the symmetry, solve this problem symmetrically, then like times 2 the answer. Okay. So so how do I approach this? Some triangles will be like this, then some triangles will be like this, then some triangles will be, so there will be like So we could I don't have my pencil right now, but I could just draw here this. If I have like that and I have a triangle like this, this will be counted twice, right? So of course, if I have at one point two triangles, I will take the bigger one. I can override the smaller. But then I need to somehow deal with this. Could be like a triangle like that, which most certainly can be the case. So I'm thinking about like doing some vectorization, doing some geometry where you cut the triangle into these small kind of trapezoids or something, and then these trapezoids, the area of the trapezoid is this plus this divided by 2 times the height of the trapezoid. So this has area this side, my side, so like A. This is B, so this is the intersection, I will call it times I, and then divided by 2 times height. This has the area. And then so the area is to the next in line here. That's how it should be thought of. So first, what do I get? So I get N, D, and H. The length of the and the height of the branches respective. So I mean, yeah, so the height is the same, but that doesn't make that doesn't kind of make a difference. And for each triangle, what you're supposed to, so there's n integers. The heights of the bases of the branches. So this point here. I don't need to sort them because this is sorted. And then you just wanna kind of go here and say, so the area here is what I said. So the base times the difference between so this is times the height So this is the base, this is the base, this is the height. The intersection we need to calculate times intersection and divided by 2. The base is, we already kind of know the base, right? D is the base. Now intersection is now the intersection here is what? How much is this here? This is, so I have something like that and I have something like that. Doesn't matter. So how much is this? So I have this side, I have this side. I can do a little bit of trick. This is the same angle, this is the same angle, these are the same angles. So isn't just this and this some kind of proportional to the angle and that? So yeah, that's correct. So okay, so what do we need to find? Okay, we want to find this angle here. This angle is well, you don't kind of know what this angle is. I mean, yeah, this angle is this. So this angle is what? Opposite over adjacent. Right. So tan of alpha will be equal to opposite, so this is the opposite side, so this is like D over adjacent, which is height over D. So okay, so this is D and this is height of this side. Now we want to say, okay, now I have this alpha here, but what is the intersection point here? It's now this actually is the same. Now I have this here, so this here is my difference, so let's denote this by diff. So now tan of alpha is also equal to some to some h minus the difference divided by h minus the difference divided by this here base D divided by like whatever we want. Actually this is what we want, and then these are, so h divided by D is equal to h minus diff divided by A, which in turn can be written as A is equal to so if I multiply both sides, I mean I want to reverse this, so diff A here, D and H, right? So A is equal to D over H times H minus diff. And this is my equation. So A is equal to D over H times this. Okay. And now what if here this is like 0? What if this is like the, so I will just add here at the end, I will add push back y dot back plus h. Then this times 2. That's not correct. Wait, is it times h? Yeah. Plus h. So on the back I just add one more triangle which has h, and then I don't account this. And this is like times h, so d divided by the d is the intersection, d is the intersection, then this is, wait, d is not the intersection, d is definitely not the intersection here. This is h minus the difference. Wait, the intersection here is, so h minus h, this is 0. The intersection here is 0 divided by whatever. Then times the intersection is 0. Oh, that's not correct. 0 is, wait, plus, this is d plus the intersection divided by 2 times this. Wait, why is, do I need it only on one side? Well, everything is correct. This is not. This is 11. For some reason. Aha, if the intersection is, I see. The intersection here is, this is minimum of h and this. Minimum of h and this, right? So I don't get this. D13. This divided by 2 times this. I would say 11 to 35. This looks great. Just submit. This looks good. Wait, wrong answer? Why is wrong answer? This one. Why is wrong answer on this one? 11, 35, 200. So it's some precision error or something. This should be enough. So does it just do that? Okay. Okay, simple version. Rudolph and Snowflake, simple version. So the only difference in this version is n goes to 1,000,000. D gets accepted. One winter morning, Rudolph was looking thoughtfully out the window, watching the falling snowflakes. He quickly noticed a certain symmetry in the configuration of snowflakes, and like a true mathematician, come up with a mathematical model of a snowflake. He defined a snowflake as an undirected graph constructed as the following rules. Initially, the graph has one vertex, then more vertices are added to the graph. The initial vertex is connected to by edges to k new vertices, k being bigger than 1. Each vertex that is connected to only one vertex is connected by edges to k more new vertices. This step should be done at least once. So the smallest possible k equals 4 shown the smallest possible snowflake. The graph is initial connected by edges to k new vertices. Then each vertex, k of these, each vertex is connected to only one other vertex is connected by k new vertices. Yeah, so the leaf vertices are connected by k new vertices. I've realized the session may not have any number of vertices. Interesting. So if there's like one vertex connected to two vertices, why is this not possible? Why is this not possible? Like, I don't understand. Why is this not possible? A binary tree to k new vertices. I don't see how is this not possible. I mean, what are the numbers here? 13, 15, 255, 101. These are all I don't know why is 2 impossible? Symmetry in the configuration of snowflakes. He defined as a directed graph constructed by So is there like a group thing here that this vertex has degree of 4, but is these are 4? This vertex, I mean, oh, with n vertices such exist, yeah, of course. Oh, okay, so that's like totally different, with n vertices, not with k equal to some number. So we want to find a function of, so want somehow to say, okay, how function of k equals some set for each k. For each k in the natural numbers, it gives up some, then this function gives some, populate some other set of numbers, and then okay, so that's, so okay, so first, okay, this is some kind of generator, like some function. First you have, should be taken at least one. So yeah, so for k it gains some set of numbers for specific k, because for k equals to 4 you could have, first you will have with this amount of vertices, whatever this amount of vertices is, this amount of vertices is equal to something, I don't know, what is this, 18, 19, 20, there's 4, there's 5, and then there's 5, and then there's 4 times 4, so 16, and 5, so 21, right? has 21 vertices, and then for each of these 4 vertices, this 16 there could be like times 4, so that's the 16 times 4, and then on this number then you could have 16 times 4 times, so 16 times, so it could be 21 plus 16 times 4, and then you could have 21 plus 16 times 4 plus 16 times 4 times 4. So f of k of I is equal to f of k of I minus 1 plus f of k of I minus 1 let's say times 4, something like this, some recursion like this. And then for a given n, then now it has to be calculated whether or not this could be the case. And n can go up to 10 to the 18, which in fact is kind of interesting. So okay, so it's just mathematical recursion. But now for a specific n, we kind of want to know how can I get this n by any k? Well, the first k is very practical. That's why it's like, but wait, this 10 to the 9 is fine, but 10 to the 18. I mean, okay, so how okay, so let's compute this. So we have 1 plus then k, and then plus k times k. That's like the initial graph, so that's like k0 is 1 plus k, and all of these k numbers, all these k vertices we add times k. That's the k0 fact. So here, because k times k, it means that I can iterate to the square root of this. So the square root of k is enough to iterate, and then I'll do something else. That's a solution for E1. That's the solution for E1. Just need up to the square root. Then f of k of 1 is going to equal to f of k of 0 plus, so all of these k times k. So we kind of want to say that this is k, f of k, and then times k. So okay, and now this can be broken down as f of k of 0 plus k of 3 plus k of k to the 4 power. This can be broken down like that. And then we want f of k 2 plus I power is f of k 0 plus the sum from j equals 3 to I equals to j equals 3 plus I or something of k of j. And sum of these numbers is some series, so this is some kind of series. That's okay to calculate, possibly. Like, you could binary search that. You could binary search and calculate this. This grows really fast. You don't even need to binary search it. The trick now, it becomes only like to find which k, like to the square root is impossible because it's 10 to the 9. So how do you bring it down at least to the cubic root? So if it's like some very big number, the square root of k would be possible. Would be possible, but okay, let's take a look at these two problems. So F and G. F is an interactive task and G is something interesting. Cultivate his random programmers, being programmer not void. There are n symptoms, number from 1 to n that can appear when affected. Initially, Rudolph has some of them. He went to the pharmacy and bought M medicines. For each M medicine, the number of days it needs to be taken is known, and the set of symptoms it removes. So, okay. Unfortunately, the medicines have side effects. Therefore, for each medicine, the set of symptoms that appear when taken, it is also known. Okay, after reading the instruction, Rudolph realizes that taking more than one medicine at a time is very unhealthy. Wants to be healed as soon as possible, therefore he asks you to calculate the minimum number of days to remove all symptoms, or to say it's impossible. But this is n symptoms that he has. This is m the medicines. Each line is a string of length n of the characters 0 and 1. The description of Rudolph symbols. If the ith character of the string is 1, Rudolph has the ith symbol. Why is no? Then follows 3 times m lines, description of the medicine. Okay, so there's this D. The next 2 lines describe it removes, and the description of the first of the 2 lines, the ith symbol removes, appears. So each day, the number of days the medicine needs to be taken. Some kind of DP, right? Something. So the medicine so each medicine can be thought of an XOR. So I can XOR this. And then for here, for the first medicine, then to the, so the first medicine will, I mean, no, so the number of symptoms is very small. This is 2 to the 10, which means it's 2 to the, it means it's, yeah, so that's a fun problem. So it's deep, it just, it's just implementation. So there's nm, there is this symptoms, so these are what it heals, what it doesn't, are the symptoms. And then we want to say, okay, we do this by saying this medicine, diet medicine, is essentially XOR between these two. And then say that, okay, so we have some medicines, we have some, so we need some DP. This DP essentially this DP is saying for until this medicine, and we have this kind of so to the n array, and all of these are like some infinite structures. We haven't reached them all, and then the symptoms dp of 0, and then symptoms 0, and then for 1 until m, and for j till 1 to m, dp of ij is min, so u min dp of ij with dp of I minus 1j. Also u min dp of I j with dp of I minus 1 j XOR the mth Madison. Then okay, and then we want the minimum C out x1 I just want to see how this there's 13, 20, there's 4 medicines here. Okay, and yeah, so this I here, whatever I is, the ith medicine is I minus 1 here. And then this dp is fine. Int infinite. If I take the X medicine, it doesn't I mean, yeah, that should be correct. One plus 4 plus 8. Yeah, that's 13. to the dpij, it means that there are no symptoms, right? It's like we want to arrive at no symptoms. But yeah, so I see. This is like the last symptoms, but you can't, it's actually like with some medicine, because this is a side effect, you cannot use it to remove a symptom. So the medicine is a bit more complicated. It says, okay, I will remove some symptoms in this medicine, so I will do this. I'll create a struct medicine in UV and then D. This. And now the trick here is, okay, I will remove from the medicine X1 symptoms. I will remove them. So it means that I can I can invert this. Have like 1n and inversion of this, and then this I can remove in this way the symbols from U. I can OR the symbols here, medicine E-1V. This would be added to it, and this is D. So this is position at I means that the medicine removes the I symbol. This -1. No, let's have a precedence here. So this is -1 This says I will take all of these, I will end them with the reverse. Now, yes, I will end with the reverse. Yeah, from the previous symbol I will remove this and add them. Add the other one. I think that's the case. New J is this. I will add everything except these, and I will remove. I will add these back. The symbols here, the symptoms. But I will need to do that. Don't I need to do that for all of these? I kind of need to do that for all of these medicines, right? I mean, technically, if I have one more for loop here. So here, how is it 0? How is it 0? Well, this, and then what does it say in the case? Say in the first example we can apply medicine number 4, after which the symptoms will look like this. Medicine number 4. After that, all symbols, after that medicine number 2, all symptoms will disappear, and medicine number 2 to disappear. Yeah, it doesn't matter like what kind of schedule of medicines we apply. It doesn't matter. So in each of like this, each of these nodes, so the symptom node can move to any of these, right? Then for each of these things, I can move to any of some other thing. So let me just do this. So let's do this like a BFS. It will say like this. Okay, so me bfs.font bfs.font. for all of the medicines. So mu j is me at this medicine if dp of mu j is bigger than dp of, I mean not BFS but priority queue. Is bigger than dp at me, dp at mu j is dp me, dp priority queue push so 0 is this 0 same so PQ, this is distance and me symptoms if dp of me is smaller than this to continue. Go like this if dp of j is smaller than dp of is bigger than dp, we go dp me plus medicine at I dot d dp nj nj. If me is equal to 0, this passes. I'm just going to submit G. Should pass. Now E1 and E2 we want to solve. Okay, gets accepted, G gets accepted. I want to solve E1 and E2 and then at the end we'll solve F. So E1 and E2. This is just mathematics. The proof of G is I think simple. There's these powers. These powers grow really quickly. So essentially for each k, there's just like only some numbers that kind of make it to k. We could go over once and pre-compute every possible initial k. but there's 10 to the 9 of them. Interesting. This 1 plus k times k, it's it's something very familiar. Yeah, this is a polynomial, right? So this is in terms, if you say k to the 0th power plus k to the 1 power plus k to the 2nd power plus k to the 3rd power plus k to the 4th power. This is just a simple polynomial. And the evaluation, okay, so this is like the sum from and the sum of squares, of not squares, of powers. And these sum of powers are actually there's something really easy. Sum from I equals 0 to I equals n of k to the ith power. Is this formula here. This formula, so to the nth power, so this is like is this formula. K to this minus 1 over k minus 1. And if we take a look into this, it's let me just see what things we are on. So we're definitely solving this problem here. 10 to the 18. So we want to see, okay, what kind of k and n can we plug in such that it gets me my n, my desired n. Okay, so what k and n can I plug in to get my desired n? Because n it is at least whatever, like at least 2 or 3, then like I would assume that some brute force is required here. So n just want to focus on this formula. N would be at least 2, right? 3 minus 1 divided by k to the third, k cubed minus 1 divided by k minus. So yeah, that would be at least. But then you want to say, where is E2? So 10 to the 18, it means that there is a solution given some binary search or something. Well, this should be equal to n, right? So we have n. And now I want to find, so here if I go n times k minus 1 should be equal to this, right? So yeah, I can if I iterate over k, I will really quickly find does n go. So is this linear somehow, I wonder? I mean, no, it's not linear, but it's monotonic. That's my thing. So yeah, so the trick here is that, okay, I can binary, no, I can't binary search. Ternary search, maybe. Ternary search against k or something like that, I would assume. I would assume that that's correct somehow. For big enough k. Okay, can I plot this? So some slider A is some slider, and then this. A times. So now k is, I'm searching against k on the x-axis, and this is some y. And now I want to find for some specific skyrockets here, but then it comes monotone. Okay, so I want to know if there's are integer coordinates x and y in this formula, right? No, it's not. This is plus 1. This is like minus 1 from this. Doesn't matter. So I want integer coordinates in this formula. If I can find lattice points x and y such that ace here. But okay, if I bind, I don't know how to find this. This look very strange. So it looks like some logarithm. But why can't go like a lot? Because if y goes a lot, then this quickly jumps, right? And the integer points on this line are practically impossible. This line goes through 1. Well, yeah, so even 100Ks. That's not gonna tell me anything here. So this formula kind of wants to find lattice points satisfying the equation. What about n? What about n? Like can I somehow search through this n here? There will exist some coefficient n. So n won't be very large. N will be very small. But what kind of, so n would be at most probably some kind of logarithm, right? And then I could search through k's which give this. I would search, yeah, so binary search over n. So search over n, but then binary search over k. So fix n and then binary search over k. That would be the case to go. So n is at least 2, right? And I don't know to where it would go, but it would certainly go. It would certainly seem to be, so I will define some here, some starting value. So this is like, I mean, no, I don't know what I will define. So n will certainly go more and more and more, right? Then I have to be careful about overflows. Well, what's the, if k is like 2 or something, doesn't matter. Let's say k is 2. Times 1 is equal to 1 plus n. minus 1. So this could be, well, like 260 and n or something like that. 60, so 60, yeah. So n is smaller or smaller than 60. Okay, and then for this I would go and I would binary search here where this k is. So k could be 1 or k could be some possibly very large value. But now here it won't be larger than, so here it should be calculated towards n in order to avoid overflows. So wait, this. So this is n, this is, say, k, and this x and x. Solve for x. Solve for x given n and k. Something like that. So k, would k be given? No, actually, wait. Yeah, n is here. Wait, k is given. K is what is k? Something of square root of n or something. Nth root. Given this and given k and n, given k and n. I would assume something about, I don't want to overflow this. I would assume something of square of nth root of k of n. Okay, I will do 1 million. Then I will just simply say like this. So this is my k. If k here to whatever n that is. So n has to be at least 2. So at least 2, it means that k has to be, k can go up to 10 to the 9 plus something. but if k to this part, so I will try here. So I will try this is k n plus n1 is binary k to the n plus 1 power. If kn dot first is 0, is false, then it means that rk is middle. Else, if it's not false, we have to check if kn dot second is bigger than okay, so I have now it's this is calculated, then -1, then divided by this. But wait, this could really easily overflow. I would assume. Do you have to program it in Python or something? I have time to switch to Python. I mean, one thing is like this. Okay, this is not like really the nth root, but it should be fine. But k could be way bigger. No, it can't be way bigger. K should be way bigger. I mean, let's see first, will it work? If k, so n times m minus 1 should be equal to k and 1 minus 1. This will definitely overflow for big enough m. If this is smaller, then RK is mid, otherwise LK is mid. I could just change them to int 128 and then it will be fine. Then I have some LK here, and then I'll need to say if that's the case. If n times LK if it's equal this will definitely overflow. I mean, that passes, but with E2 this will definitely just overflow. I don't like this. So let's just define long as int now here this is not this has to be okay. I will submit to E1. See if this will work. Compilation error. I need 20. Okay, this kind of works. This gets accepted. Okay, E2. And we need F just to solve F. I'm going to exceed it. I mean, yeah, the 128-bit operations are very slow. This is not slow. This is log times log times log. Let's just use this is slow. This here could be done in everything of this could be done in no, really no. Like this check is not necessary. Like something about the nth root. So let's just the nth root. Where's was the nth root? Double nth root is n. 1/n. this should be faster, way faster. Okay, so let's see this. So it's an interactive problem. So this gets accepted. So this is an interactive problem. There's actually one amazing creature, a mimic that can turn into any objects. So in front there are n objects, and exactly one. He has already disguised himself in the room, and Rolf needs to find him by experiment. The experiment takes place into several stages. At each stage the following happens. Rolf looks at all the objects in the room and writes down their type. The type of each object is indicated by a number, and there can be several objects of the same type. After inspecting, Rudolph can point to an object he thinks is mimic, and after the experiment ends. Rudolph only has one try, so unsure. Okay, can remove any number of objects from a pass with 0, then Rudolph leaves the room at any time, including are mixed with other objects. The order is changed. The mimic can transform into any object. After that, Rudolph returns to the room and repeats the stage. May not change appearance, but it can remain the same object. Rudolph tasks no more than 5 stages. Object types. So there are n objects. There are some object types here, and then so the output. So here we can put away 1 and 2. So we can put away this position of the mimic, 5 requests from cancel. The mimic can change to any object. To remove the object, print this. After that, k number, how much k number indices the object current location. So first it removes 1 and 5, and it left with these here. Also one object, and this is the 5th, and then removes 1 object. This is the 3rd. The mimic changes position. Removes 1 and 2. He says the same. So the shuffling So the mimic will change appearance, and because there are exactly 9 things, so we can just like remove everything except like the mimic thing. That so after like 2 stages there will be can I remove nothing from the first stage? Possibly 0. So yeah, so technically I can remove nothing, and then after 2 stages there will be a change in frequency. And as soon as it changes frequency, I know what type is the mimic, and then when I know what type is the mimic, I will remove everything except this type, but still I don't know which one it is. Then I will wait for 2 more stages, check, mimic will turn out to be another type. I think we can solve this one as well. So the mimic is okay, so then I go over all of these. If AI is equal to the, is not equal to the mimic, then I will say I will turn this, then I do 2 more steps, and that's like I remove get new A and then I see, I will so check. It could be totally wrong, I'm not sure. Didn't have time to even check it, so it would be surprising if it works from the first try. But okay, yeah, that's the pretty much, I think, the idea behind the task. So I'm just checking like the frequency and the mimic, because after 2 rounds it has to change. The frequency will change as well. So yeah, we got the wrong answer because of something. I didn't even check. Incorrect query. So what's this incorrect query? Possibly you can remove possibly 0 elements, right? You can point on object. Roof can remove possibly 0 elements. Incorrect query. I don't know what. What does that mean? Just test it out. So like first there's wait, what is 3? Wait, what is this 3? What's this 1? Okay, this is like a okay, so this is a hair, whatever, doesn't matter. So it's like 3, and then we have 5, and then we say okay, the mimic 1 1 2 2 3, we delete so 1, and then okay, so let's just make it the same, and now we will make more 3s, let's say like that. Well, the frequency, of course, like here there would be n, but then after like I remove, there should be like n minus whatever I removed. But here also this I will fix it off camera. We'll fix it off camera, but the idea is that, so I don't know. The idea is that. The frequency of this is, I mean, yeah, so apparently, yeah, G apparently was easier than F, but I think F is way easier. I just don't. Yeah, here I can't overwrite mimic -1. That's my bad. And here is like minus removed. Here's also like minus removed. Here when I remove it, yes, of course, this is incorrect query because I need to know how many in advance I need to remove. And print all the elements, print end line, so this is like remove, and then like I will repeat this is n minus remove, and this is n minus this apparently. This should work. So if I have this, then maybe I do the same thing. Then I like change one of them. I remove 2 and 3 and 5, which that's correct, and then like I have 1 1 1, which again yeah, so I need to do this. So I start with 5, and I start 1 1 2 2 3, and then I say 1 1 1 2 3, then I say 4 and 5, then I say 1 1 1, then I say 1 2 1, come on, this should work. get home to install test 1. Query was not received. So I will try to fix it later. I don't know. I'm a bit tired. Try to fix it later. So something here I'm not printing or something. Here there's like should be removed, and then there's the reading of this. Maybe I should do form here in case. I don't think so. I don't think that's the problem. However, the contest was good. Just go over simple. So yeah, A, you just had to see this kind of equation. B was about just checking out tic-tac-toe, so nothing fabulous here. Here just print, just calculate this time and something, and then print the sorting order. I mean, not the sorting order, but just which had to be. I use this iota function just to fill up this order array. But in which place do you end up in? Then D was like, I mean, yeah, D was a bit strange, just because of this. I solved it using this formula for trapezoids. I just cut out this triangle. I cut out this triangle to the next one, and then to calculate all of this I just used a little bit like a trick here, calculate this, and then this minimum means if like the triangle ends up in a position like this, so like in position where the other triangle is over here, I will just make this, I would just like minimize it right to here. The difference between this here and this here is at most my height. And this means there's no intersection if the next triangle is way there. This is what it means. It's just, yeah, it's just, and you have to use this fixed set precision thingy. Just this thing here, we usually set to 16 decimal points or something like that, but it just prints out the, so if C++ probably sees that there are a lot of 9999, it will just like round the number instead of like here this is the correct answer, it's not rounded, it shouldn't be rounded, it should be like set precision. So set precision, fixed and set precision is just like saying, okay, there will be like 10 decimal points of precision no matter like whatever you try to do. It doesn't round more than that. This E1, I mean E1, yeah, sure, like E1 was just like think this polynomial and then trying to see if there is so if there's some formula that that you can plug in k and n to get this. And if there is such formula, then it's yes. So apparently, yeah, so apparently I don't know how to do E without like in 128 or maybe like big integers or something. It's kind of weird that it must overflow. This here overflows even long, but not sure how you pull it off without them. So you kind of build this, you build some table and then you binary search. Yeah, I thought about this, but I thought that like you need to go a lot further than that. Yeah, apparently, yeah, you could just hard code this and then that's the cubic root. So apparently, yeah, apparently you don't need this. Yeah, he used integer 128 as well. I don't know. For me, this kind of like this is really fast. This is log times log times log. It's not even log times log. It's this is constant. So yeah, f we didn't solve, but f is just this. It's just saying the frequency, how the frequencies change, and when they change, you need to just what changes will be what changes there will be this mimic. Actually, like where the new frequency is bigger than the old frequency. This is what we want here. Where the new frequency is like strictly bigger than the old frequency. Maybe this is why we fail on F. Let's see. And then G at the end is just Dijkstra width. Okay, F gets accepted as well. Okay. So G is just Dijkstra at the end with. So G at the end is. You want why is it greedy? It's because like you build a graph and then you want to find the quickest path from this vertex, which is like what your symptoms represent, and you want to find what is the last vertex is the 0 0 0 0 0 0 0 vertices. And from one vertex you can move to any other vertex that satisfies like from one vertex with like any like of these m medicines, you can move to other vertex by applying this medicine. So this medicine is applied, I applied just with bit masks just to get like fast calculations, but this here means I'm deleting all of these u's that are, so all of like the symptoms that this cures, and then I will add the side effects that this adds, and then the dp of nj, if it's bigger than me plus like whatever this medicine costs in days like to be treated, then it means that there's better way of arriving there, and it means that there's better way of arriving there we can push on the priority queue that, and just like simple Dijkstra. Why it works, why there are never negative cycles, and there are like, yeah, if there's no negative cycles, then like the shortest path in this graph is always it can be always found with priority queue, with the Dijkstra. So yeah, this is it. Thank you guys so much for watching, and I see you in the next CodeForces or Red Code round. Check out my channel for more. Thanks.